Let's spend some time practicing naming molecular compounds. Again, just as a reminder, molecular compounds are basically your nonmetal compounds. If you look just to the right of your stair step, it's basically anything over there. So basically, this portion of the table has its own set of naming. It's because they undergo their own set of chemistry. They can combine in a lot of ways. And we're going to be naming relatively simple molecular compounds. Okay. They can get much more complex. You get into other classes, you'll learn naming there as well. But we're going to be naming basically the elements on that side that are called binary, meaning they just have two elements. Doesn't mean they only have two of that element, it just means only two elements are present. That's what we're going to primarily focus on. But in order to name your molecular compounds, we first need to understand there are some species that exist as molecular elements. So, what that means is the element by itself is not just a single atom of that element, but the element exists as a molecule as well. And that happens for a handful of them. We have seven elements that exist as diatomics, meaning two of them paired up together. And then we have four more that exist as a polyatomic, meaning more than two elements paired together. And we can see them here. Our diatomics, hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, iodine. Okay. They exist as H2, O2, N2, F2, Cl2, Br2, I2. What do I mean by that? I mean, if I say oxygen is reacting, I'm actually talking about O2, not a single atom of oxygen. Whereas if I said carbon was reacting, I'd be talking about a single atom of carbon. You have to know your diatomics and your polyatomics. So there's a few different ways to memorize these. Most students use mnemonics, which is totally fine. One of the most common mnemonics for your diatomics is have no fear, of ice, cold beer, H for hydrogen, N for nitrogen, F for fluorine, O for oxygen, I for iodine, C with the L for chlorine, and B with the R for bromine. Okay, that's one way to do it. Totally fine. The way I have it memorized is that I know it's not as helpful. The mnemonic is more helpful. I will admit that. What I know is that I'm going to start at atomic number 7 on the table, and I'm going to form a 7. I go three across and four down, but that only gets me six of my elements. I then have to remember that hydrogen is also one of them. Okay. But sometimes marking them on your periodic table can help because that can help you find your polyatomics. If I mark my diatomics on my table, my polyatomics fit in this really nice little square snuggled right up to that 7. I know only three of them are listed on the table. I do have all four listed down here. Um, Arsenic also does this, but sulfur and selenium like to be 8. Phosphorus and arsenic like to pair up in groups of 4. How do I remember that? I remember 2, 4, 8. Okay, so I just remember 2 doubled is 4, doubled is 8. I remember that. And then to me, an S, sorry, I have the wrong function on. An S is like an 8. But the two down both do 8. These two down both do 4. And you just have to know that. So diatomics, 7 elements which exist as diatomic molecules, and they actually occur in form. You must memorize these. You really truthfully also need to know P4, AS4, S8, and SE8. But again, you can get these off the table if you know your other 7. Molecular compounds, how do we name them? Molecular compounds, we're going to name binary, which means only consisting of two things. These consist of two non-metal elements. You name the first element listed with its regular name. You name the more electronegative element with the "ide" ending. How do I know it's more electronegative? Because it's coming second in the formula. You guys won't learn electronegativity for a while, but the second element listed in the formula is going to be the one that has the "ide" ending. You're going to use numeric prefixes that correlate to the number of that specific atom in the formula. If the first element listed has only one atom, no prefix is used. So we don't use mono at the beginning of a name. Our prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, just like they were for the hydrated waters, if you've watched the ionic naming video already. So a few examples here, N2O5, I have two nitrogens, so I'm I'm going to say di to emphasize I have two of them, and then nitrogen. I have five oxygen, so I'm going to say penta for the five, ox for oxygen, and I'm going to change the ending of the name to ide. SF6, I have six fluorines, only one sulfur. I'm not going to write mono in front to emphasize sulfur. By me just writing sulfur, I'm emphasizing I just have one of them, but then I'm going to say hexafluoride. PCl5, phosphorus pentachloride. Again, another way to kind of show like this example is CO versus CO2. Most people are comfortable with this just from everyday knowledge. CO is carbon monoxide. I'm using that mono for the second element listed. CO2, carbon dioxide. Okay, so the mono will be used if it's the second element listed, but not the first. If I have NO2, I call this nitrogen dioxide. But N2O4, dinitrogen tetroxide. So we're not going to use mono at the beginning of the name for the first element listed if there's only one of them, but we will use mono if there's only one of the second element listed. I'm not just going to call it carbon oxide. I'm going to say carbon monoxide to emphasize there's only one of them. So let's work some examples. Oh, I just gave you the first two without thinking about it. Carbon is just a C. It doesn't have a prefix to it, so that means I just have one of them. The ide is just the ending for the second element. So I look before that and I see ox. I know ox means oxygen. And then mon means one. So I just have one of them. So the formula is just CO. Carbon dioxide, carbon, just a C. Again, ide is just the ending. Ox tells me I have oxygen. And di tells me I have two of them. Dihydrogen. So I have hydrogen, but I have two of them. Monoxide. Ide is just the ending name. Ox is what I have. And mono tells me one. Dihydrogen monoxide. Boron trichloride. Boron, capital B. The ide is just the ending. The chloro tells me the element I have. And tri tells me I have three of them. Dinitrogen tetroxide. Again, di tells me I have two of them, but this is telling me the element. Nitrogen, and I have two of them. Ide is just the ending. Ox is the element I have, and tetra means four. Notice I'm not saying tetraoxide. It just looks weird. I'm not going to put the vowels next to each other like that, so I'm going to drop the A and say tetroxide. And then, so you keep the A if you don't, if you have a consonant next, if you have a vowel, you're going to drop that A. Sulfur hexafluoride. Sulfur, I know, is just an S. The ide is just the ending of the name, so I've got fluoro, which means fluorine, and hexa, which means six. If I want to go the other direction on it, going from formula to name, I've got PCl5. I know P is phosphorus. I know Cl is the chlorine, but I have five of them. So I need to say penta for five, chloro, but I'm going to drop off the ine ending for chlorine and write ide. So pentachloride. CCl4, the C in front is carbon. I know Cl is chlorine, but I have four of them this time. So I'm going to say tetra for 4, chloro or chlor for chlorine, and then "ide" for the ending because the second name, the second letter, second element listed will always end in "ide." CS2, C is just carbon, and I only have one of them, so I just don't need to specify how many. I only have one, and I have two here. Two is di, and then S is sulfur. So I'm instead of writing sulfur, I'm going to write sulfide. CO again, carbon. I have one oxygen here, so I'm going to write mono, but then it's oxygen, so oxide. So carbon monoxide. XE is xenon. I only have one of them listed, so I don't have to put a mono in front, but I have 6 fluorines, hexa, fluoride. This one is a little unique. We'll talk about this when we talk about acid naming, but when you have HCl, most of the time HCl will be a gas or will be an acid for you guys, but normally we list it as aqueous, meaning it's in water. When HCl gas is bubbled through water, it makes an acid. In this form, when I'm emphasizing it's a gas, that means it is a molecular compound. So I'm intentionally emphasizing it is molecular here. So this one I would name hydrogen, monochloride. It's completely correct. Now, we will talk about this more throughout the semester, but hydrogen can only ever have one bond. It cannot go past one bond. It doesn't have the ability to bond more than once. It doesn't have the space for any more electrons. So most often you will see this actually just called hydrogen chloride, and that would be accepted for this species, but that's because hydrogen cannot have more than one. It can't have more than one thing bonded to it. SO2, S is sulfur. I have 2 oxygens here, so di, ox, and ide for the ending. SO3, I have sulfur again, only one of them, but now I have 3 here, trioxide. Molecular naming tends to be easier for students. It's really memorizing your diatomics and your polyatomics of your molecular elements. And then not forgetting your prefixes. Remember which prefix is which. Also, again, just a little bit back to those rules. Remember, if the first element listed only has one atom, you don't use that mono prefix at the beginning of the name. We only use that mono prefix for the second element listed. But if the first element listed has more than one, example, N2O5, N2O4, we do put that prefix in front.